My presentation is a research on bulging deformation and the cracking failure of long-term service chromium molybdenum steel cook drums, and I'm Zhiyuan from China Special Equipment Inspection and Research Institute. This is the outline of my presentation. The first part is the background, and we know the drums are critical equipment in delayed cooking plants, and it experiences thermomechanical conditions by the cyclic heating and the quenching process. So it also experiences thermomechanical fatigue damage. So it's very prone to bulging deformation and cracking at the weld. It's very common for this equipment. And the manufacturing material of this equipment mainly include two types of materials. One is carbon steel, and another is the chromium and molybdenum steel. And over the past 2 decades, the chromium molybdenum steel cook drums have gradually replaced the carbon one in China due to its better strength and deformation resistance. However, in recent years, we have found this kind of cook drums experience the critical through wall cracking after 15 and 20 years. And it sometimes results in the leakage and failure and unplanned shutdown of the plant. So we are very concerned about the failure mechanisms and the influence factors of such cook drums. And also there is some research, especially the US, we know the API 934G, they have many data, but we have no such data in China. So we did this study to know how to maintain it and improve this failure problem. And so this study is conduct the inspection and the data collection of several these chromium molybdenum steel cook drums, and we use the laser scanning inspection and also to did this method to construct its construction the deformation profile, and we also use the miniature sampling tests to obtain the properties of the material, and we also use the finite element simulation to obtain the strain and the stress of the during this process, and we concluded the reason of the failure and also give some suggestions for prevent the failure problem. And so the next is the achievements and the results. This is we did about 14 cook drums data, and we use the laser scanning to obtain its patient profile. And here we can see some sample. We can see some deformation is at the top of the cook drum, and some of them are concentrated at the bottom of the cook drum. They are different location, I think. So we it's frozen. Reason.
Sorry.
Sorry. Okay. So we analyze the data, and we can see old cook drums show less than 90 millimeters of the bulging, and over 2/3 of them less than 50 millimeters. And we can see the location. Some of them are at the top of the drum, and some of them are located at the bottom of the section of the drum that is not consistent. And also we studied the most severe cracking, means the through wall crack. They are concentrated in the middle section of the drums from 9,000 millimeters to 16,000 millimeters, the distance from the bottom weld. And so I think the location of the maximum bulging location is different from that most serious cracking location. And we okay. And we also see the crack, both internal and external surface. We both found the crack. And also we did some mechanical property tests, and this is case 1. And this is a cracked cook drum, a very serious crack, and through wall cracks. And we take the sample from the failure material and at the cracked weld, and we can see the elephant skin cracks here, and So the microstructure of the material is normal, but we don't there's a many discrack, and we didn't see the severe oxidation or the creep damage we didn't observe. And we also use the instrumented indentation method to measure the mechanical properties, and we can see in this case the base metal had slightly higher strength than the weld material, and this is consistent with the hardness test. So we can see there's some weakness in the weld structure. And next, this case two, we also studied another one. This is a crowded and cracked hook joint, and we can see the crack initiation at the bottom of the corrosion piece, and this material microstructure is also remains normal, and also we test the hardness. We can see the weld hardness is slightly higher than the base metal. And this is case three. We take a sample from the replaced shell, and we test the tensile from the tensile test for this material. And this is a corroded hook joint, but no crack was found. So the results indicate that the weld strength is significantly higher than that of the base metal. So from these cases, we can conclude that the strength of the higher strength of the welding material may important help for the resistance to crack, and also the stress concentration due to the corrosion case and due to the change of the thickness and also the deformation of the bulging will promote the cracking initiation. And next, we perform FE analysis, and we consider the both quenching process for normal operating condition and also the cold spot effect. And here we establish the FE model, consider the deformed shell, and we also consider the cold spot effects that during the quenching stage. And we also use the dynamic the thermal boundary analysis to make sure the temperature curve simulated is the same with the measured one. So at last we calculate again and again, and then we get the temperature and the stress profile. And here we can see the results. The maximum stress was appeared at the quenching stage, and the maximum stress is about 140 megapascal. And such stress and strain seems impossible to cause the severe plastic cyclic deformation and fatigue of this material. And for the cold spot condition, we consider cold spot. We can see cold spot have lower temperature comparing the surrounding metal. And here we can see the maximum stress reached about more than 300 megapascal. And this may cause the plastic strain and also the low-cycle strain fatigue damage for this material. And so from the above results, we can discuss some two things. One is, I think, is recording the results we simulated, and we can use coffee massing relationship to calculate the fatigue life of this cook job, and we obtained 9,400 circles life, and this is greater than 3 years. And so that does indicate the cold spot effect is important to cause the thermomechanical fatigue failure. And we also know the instability during the quenching stage is an important factor that can lead to cold spot and abnormal strain in the cook drum. And also we we simulated the normal operating condition. The quenching rate is about 3 centigrade per minute, and for the cold spot condition, we found during the actual operation history, we can find the quenching rate can reach 10 centigrade per minute sometimes. So the cold spot effect really exists during the operation. So we suggestion is the operator should carefully control the quenching process operation and increase, for example, increasing the steam flow during the cooling stage and reduce the finishing rate against the subtraction. And another we want to discuss is the relationship between the deformation and the crack. And we can see the laser scanning inspection data from the carbon steel, hook joint, and the maximum deformation can reach over 200 millimeter. However, no cracks were found in this bulging area. So for the chromium molybdenum steel, the cracks will appear even the bulging deformation is still very low. And we also can conclude that the insufficient stress of the welded material, the stress concentration caused by the corrosion piece and change of thickness can be the causes of the cracking. And it's also indicated that the severe crack error is not related to the maximum bulging and located at the middle section of the cool joint. So based on these results, we strongly recommended that we should conducting 100% non-destructive inspection on both external and internal surfaces of the wells at the mid section of these cook shops during long-term service. It started after 15 years service, I think. So that is the conclusion. We concluded the reason for the failure and gave the suggestions for the operation, also the suggestion for inspection. And now several big plants in China have accepted this suggestion. They did more inspection and have a regulation for its operation now. And I think this will improve the management of the people in China. Thank you. Thank you.